Alright, so I want to talk in this video a little bit about the telemetry unit and show off. I take it apart, show some of the components inside of it, show the back of it and how it's networked. I figured I'd do that now because, as you can see, it's a little bit difficult to get to. You kind of have to take all this stuff apart to get this machine out, but fortunately the front panel comes right off of this. But the parts that are in here are pretty static sensitive. So you definitely want to take caution when taking this apart, but even if you don't want to do that, this video will hopefully answer any questions or curiosities you might have about what's inside of here and how it's structured. So I actually didn't bring a grounding strap with me today. I forgot to bring it and I can't seem to find one in here, so I thought I might take this time to go over some aspects of grounding and how it works and try and clear up some misconceptions about it. If you've had A+ or any kind of computer repair class, they usually tell you or suggest that you ground yourself before you work on the computer, but I've found the explanations for this not exactly super great, and there's some misconceptions about what grounding is. And so the common thought behind grounding yourself is that you're getting rid of static electricity, and that is a large part of it, but a more important part of it is that you are taking your body's voltage level and making it the same or referencing it to whatever you're going to work on. So the voltage of your body will be the same voltage as the motherboard or the computer or whatever it is you're going to work on. Right now, let's say that both you and the computer are not touching or not referenced to ground in any way. You're both floating in reference to each other. So let's just say, I'm going to make up some numbers. Let's say the computer is at 3 volts, a reference to ground. And let's say you are wearing socks and shuffling them on the carpet. Let's say your body's voltage has gone up to 2,000 volts. Now that would be a problem. Generally, it's not a problem for you because if you touched, the classic example is touch a doorknob, you get that little zap of electricity, and your voltage level is going to dramatically drop like this. And it will sting, but there's not going to be a lot of current going through you to the doorknob, so it's not going to be harmful. On the other hand, though, this kind of presents the same situation. If you touch this computer, there's going to be basically a bolt of electricity going from you to whatever metal part in here it comes into contact with. And that's a pretty big difference in voltage. And even though it's not a lot of current, that's still enough voltage to damage parts, because these parts are generally only rated for 12 volts, something like that. And that is plenty of voltage to basically kill components on a motherboard or a computer. So instead, what they might teach you to do is to touch the case of the computer before you touch anything inside of it. And what that will do is will take your body's voltage, static electricity, and dissipate it over the entire computer case. And inside of your computer, your motherboard and all those components are going to be bolted in to the case. So in effect, what you're going to do is you're going to make the voltage level between you're going to equalize the voltage difference between you and the case of the computer, and therefore the internals of the computer. So you might even be wondering at this point, what's the point of a grounding strap? There's actually a couple different reasons why you would want to use a grounding strap over just touching the case or some other method of directly grounding yourself. One of them is if you're working in an area that has a lot of flammable chemicals and that may be ignited or combusted by a spark. You definitely don't want to just touch something willy-nilly. At that point, you would want to have a grounding strap that would dissipate the electricity more gradually. So instead of it dissipating your electricity like this and having a spark, you would instead use the grounding strap, which would pass through the resistor, and you would have a voltage decrease that looks something like this. Another aspect of this is this method is only useful as long as you are still touching the case of the computer. As soon as you let go, there can start to be a drift between you and the computer in terms of your voltage levels. And at that point, it may not be enough to be noticeable spark, but it could still be enough to cause damage to the computer parts. if you touched a circuit or something in there. There could still be enough potential difference between you and the computer to cause damage to a component. So with this circumstance, if you're working on a computer and you have a grounding strap between you and the computer and you're not connected or referenced, or neither of you are connected to earth ground, the computer is now safe to work on because you and the computer are now at the same voltage potential. So the chance of there being a spark is basically zero, and ideally your body's voltage level and your computer's voltage level will be the same. But an important fact to keep in mind in this scenario is that only you and your computer are now at the same potential. If you're working on multiple computers or multiple devices at once, these other machines are in their own little bubble, and they could be very different voltage levels between you and these individual machines themselves. So that kind of presents a problem, and there's a couple ways you can get around it. You might say, oh, I can just have a grounding strap for each one of these, or run wires between all of them and link them all together. As you can see, it kind of becomes a mess, and there's an easier way to do it, and it really emphasizes the importance of having a proper grounding strap. So let's say that this is the same scenario, but you want to work on all these machines at the same time, or these machines are test machines and you want to use them in conjunction with this machine, whatever. The easier way to do it, and the more common way to do it, is to take your test computer, plug it in, but the power supply, there's a switch on the back, and you switch it to off. And what that does is it will cut the hot line off of the incoming cable, or the power supply is hot, and instead leave the neutral and ground connected. And inside the power supply has the ground connection going directly to the case. So now, in effect, because your outlet is mains earth referenced, your computer is now also mains earth referenced and all the stuff inside of it. And through your grounding strap, now you are at the same potential as these machines. And if you plug them in, if you plug these machines in as well to do the same thing, now all of these machines are at the same potential, including yourself. And even in this case, you can not even have a connection between you and the computer. You could have your grounding strap connected to something else. You could have it connected to something else that's grounded, but it doesn't really matter because the grounds on here are all going to be the same potential, and the effect is going to be the same. Another way to ground yourself would be something like a power supply, like a lab bench power supply like this, which have the positive, negative, and the ground terminal. And this ground terminal actually goes straight through the device into the outlet's ground port. So this would be effectively the same as connecting your alligator clip to the power supply or the case of your computer. But for the sake of simplicity, let's just say that your grounding strap is connected to your computer, because that's the easiest way to do it, and this only works if you actually connect it, if you are actually referenced to the machine you're working on. And the easiest way to do that is just to connect the grounding strap to the machine you're working on. But this really presents the primary reason why you want to use a grounding strap, a proper grounding strap with a resistor, and not just touch the case of the computer or use a bare piece of wire or something. Let's say that something with this machine goes wrong and its output or its case or something gets set to mains voltage. Just as a hypothetical, if you didn't have a grounding strap and you just touched the case, and then you touched this machine over here, or the output, or whatever it is that's at main voltage, well, now you've got a problem, because now the voltage is going to go through this machine, through you, through your arm that's now connected directly to earth ground through this computer. It'll go through your computer, through the outlet, into ground. And you are now having a bad day. But instead of potentially electrocuting yourself, you can be smart and use a proper wrist strap with a very large resistor between you and whatever it is you're working on. This doesn't solve the problem that this machine is broken and still putting out dangerous mains voltage. Whatever that happens to be, whether it's a exposed conduit or a piping that's gone to live voltage, or it's a machine that's broken, there's 1,000 different things that can happen to cause this particular scenario. And often it's protected against, but not always, so better safe than sorry. Anyway, use a ground strap, because what this will do is it's the same situation in that the current, or the mains voltage, is going to go up into you through the ground strap, through your computer into ground. But instead of it being a direct short, now you have this 1 mega ohm resistor or more between you and ground. So now you look something like this. So this resistor is going to drop the current to a astronomically low level. We're talking milliamps or less, probably on the order of microamps at that point. And even though this danger still exists, you're not going to immediately get electrocuted by having yourself referenced directly to ground. So in this aspect, in this particular situation, the grounding strap is acting more as a safety device for you than anything else. All right, now going back to the telemetry unit, which has all been powered off. All right, so after removing the front panel screws, go ahead and take the front panel off. And you can see in here, there's actually not a whole lot. Well, most of this room in here is reserved for other boards. Back there you can kind of see the computer, the embedded computer that's driving all this stuff, but this right up here is the actual telemetry board, which is the part we want to see. So to remove this, you just want to use these white tabs and pull outwards like that, and it will release, and you can just slide it out. As you can see, most of the stuff is underneath of this heat sink that goes on both sides, so you can't really get a great idea of what's inside of this, although you can see some components on the top here, maybe some controllers and power supply regulation, stuff like that. There are status LEDs on the top here, but really that's about it. Got the connector. When you're putting it back in, there's only one way it can go back in. You just want to match up the side of the panel. You can also look for the silk screen and the stickers, make sure that they're facing out, because on the other side I don't believe there's any stickers or even any silk screen markings. At least nothing like this, no labels on the silk screen. But when you put it back in, each side has a track, and you want to put the board in between both of those rails there. So you want to make sure that this is like right in between there on both sides. Oops. Trying to do this one-handed is a little tricky. There. So you'll see that the board is on both sides being held up. You can't really see that, but it's being grabbed both sides by that rail, and then you just push it in. You want to make sure that the tabs here are both set to face inward when you put it back in, and just push it. That's it.